Hello, everyone. Welcome again to another Tech Talk in Howdy. This time we're going to listen to Juli Garcia in his talk about blazing fast. So I leave you with him. I hope you enjoy it.
Cuidado con la cámara. Hello. Hi, everyone. I'm Juli Garcia, and we're going to be talking about Next.js and how we can improve performance on our web applications, mainly focused on landing pages and websites that really need to take advantage of optimizations for SEO purposes. So, against popular belief, front ends just don't only change button colors. So we're going to be taking a look at most of what I've been doing the recent months and all the complexity that lies behind this kind of tasks. So obviously, welcome, first of all. So we are going to be talking about the project setup. This is just like a quick overview on how we set up the project on MetaSmart, which is my current partner, what tools we're using, and for what purposes. We're going to be having like a quick overview of what SEO is and how we measure performance. Then we're going to be doing a quick comparison between server-side rendering and client-side rendering, image optimization, font optimization, script optimization, and we're going to have final comparison of performance on the web. So first things first, let's set up our project. So what tools are we using for this? So basically, what I was making this demo, I was thinking, so maybe I should start a new project. Maybe I should like build something. And then I thought like, well, I already have the landing page I built for MetaSmart. So why don't I start there, which is a really highly optimized website, and just de-optimize it to make it really, really slow? So that's what we're going to be seeing. We're going to see the results of highly optimized websites, and then slowly how it progresses into a really sluggishly slow one. So what tools do we use? So we wanted to share components, we wanted to share utilities, we wanted to share functionality across all the web applications that we have. We currently have 4, one of which is the landing page. So we're using Turbo Repo, which is basically a building application for front-end applications that it's built on Rust. It's really fast. Most of all, it's made by Vercel, which is the group behind Nextjs. So it's basically the best you can use to deploy Vercel Nextjs applications, basically. We're going to be using Nextjs, which is one of the most modern frameworks that we have for building React-based web applications. And then and this is something that I'm using personally, but I use Node just to manage the versions of Node, because you might want to be using the latest for this, but you might also want to use a different version for another project. So the setup is really simple. We install Node, the latest version. You can make it global. You can make it local for this project. Then we have to install Yarn, and we can use the create turbo and latest to create like a demo project for this purpose. When you create a demo project, you're going to have 2 separate main directories. The first one is the apps, and the second is the packages. Apps basically has 2 separate web applications that leverage Nextjs for its build. And packages have several configuration packages like ESLint, TypeScript configuration, and they have a separate UI package. So this is a really basic configuration, but MetaSmart web architecture basically bases off of this. We have 4 applications instead of 2, and then we have several packages that include webhooks, utilities, and typings. So it's really this simple to set up a similar project. If you want to start coding and you want to start using Nextjs, I really recommend this configuration. It's really easy to scale across different applications, and it really ensures that you're making the most out of sharing the code between apps and keeping consistency really, really high. So I don't know if you've heard, but SEO is pretty much one of the buzzwords in the web industry, right? Like SEO is everything currently. If you're a web developer, if you're a front-end developer, you most definitely have heard about SEO. and you might have some like a boss that comes to you and says, hey, we need to optimize for SEO, we need to have a really good site for SEO. And like if you had the same struggles with me at first, like you don't really know what SEO is and how you can improve it and what's it all about. So we're going to be having a quick overview about this. So SEO is basically search engine optimization. So when, for example, we submit a page on the web, search engines like Google or Bing, they measure our site's kind of attributes, be it SEO optimizations for a really semantic website or a high performance index for speed. They use these attributes to index your page on the organic searches. So in practice, basically, we want to make our website be in a really high position so that we can leverage it for to appear in more organic searches. When people search, for example, how can I do this? Then one of our blogs can respond to the question. We can leverage that to make our brand get bigger, right? So how does Google or Bing actually index your pages for these kind of searches? So here's when crawling comes in. Basically, you can submit your site to be crawled by Google. Google has several bots that basically take advantage of what you build and go through all the pages that can be indexed. They search for interlinks between pages so that it makes it more compatible. And then it comes up with a ranking that they later use for basically coming up when how are you going to come up in searches. So maybe my page is really speedy, and that's how I can win the fight between another competitor on an organic search. So I'm going to come up with a higher rank overall. So how can we make crawling better? And this might be something that's pretty basic, but I think the devil lies in the details, right? Like if you mess something like this up, then your site is gonna get less traffic. You're gonna have to pay more for ads, and it's gonna cause a lot of headaches. So the first thing is architecture. We're gonna form, and again, this seems pretty intuitive, but you kind of need to make a tree form, right? So you might have blogs. So you're gonna have the homepage, then you're gonna have the blog page, and then you're gonna have several individual blogs, which are gonna be kind of like the leaves of the trees. You don't want to have orphan pages. These are not gonna be easily indexed. That might be what you're going for, but if you need the page to be indexed, you don't want it to be orphaned. This means you're gonna have to be direct linkage from other pages, and you're gonna need to have it interlinked in between pages. And then we have a sitemap, which is what it basically says in the name. We're gonna build map for the site. So we're gonna tell Google or Bing or whatever search engine we're using what pages we have, and like we're gonna give it access to them. Then from that, it's gonna crawl through the HTML file. It's gonna look for another links, and that's how it's gonna be discovering all the pages. So if we want our web to be indexed correctly, we have to tell the crawl bots how to go about it. We need to tell them, hey, this is my homepage, this is my about us page, this is my blog page, and I have this amount of blogs, right? It's a XML file, it's static. You can have it in the public folder on Euchre. You can build it whenever you change something in the app. So then this is pretty much like an overview of what SEO is and what can we do as a developer to improve this, right? So the first thing, and again, this might be pretty straightforward and pretty basic, but when you come up with a website, when you buy a domain, you're gonna have basically two main addresses or names for your website. You're gonna have the domain.com, or you're gonna have the worldwideweb.domain.com. And if you don't redirect them correctly, and if you don't set your environmental variables correctly, then you're gonna have a constant redirect between pages. This is not good for indexing. They're not gonna get indexed correctly, and it's just like wasted potential here. So basically, you can have, for example, www.domain as your main domain. And if someone comes from the non-World Wide Web domain, they are going to get redirected there. You are going to want to have the main site as the redirect links on the sitemap. If not, your pages are not going to be indexed. Then we can improve our page speed, which is basically what this talk is all about. And then there's a lot more things that you can do, such as you can have a more semantic HTML document, you can have a different structure, you can make a lot of small changes that are going to aid, for example, to people that are visually impaired or need translators on the web page to kind of go through. So all that is considered in this SEO score. But we're going to mainly focus on performance and speed. So how can we measure performance? So we're not going to measure it. We're going to let Google measure it. So we're going to take its parameters as what's speedy, what's not speedy. So we have three main parameters here. There are a lot more, obviously, but we're going to focusing on the three main ones. So we have the largest contentful paint, which is basically how long it takes for our website to load the biggest part of the viewport. So for example, if we come into whatever website we want, the first thing we're going to see is a headline, and we're going to see a hero image, right? So if this image is really low, really big, and it takes too much time to load, this index is going to plummet. Then we have the first contentful paint, which is basically how long it takes to render the first piece of whatever is going to be in the viewport. And then we have the speed index, which is some calculation that Google does, taking into consideration all of these parameters and more to kind of tell you, hey, how fast your site is. Are you blocking the main thread? Are you doing stuff correctly? All this is going to be taken into consideration when coming up with all these indexes. So again, before we start getting into all the good stuff, we still have to talk about server-side and client-side rendering. So what does it all mean? Obviously, we have client-side, server-side, as I said, and we have one special type, which is the one that we would really like to have, which is static side. But in order to get there, we have to understand the previous types of rendering, and we're going to have to make some smart moves and some smart optimizations. So client-side rendering, basically, it makes a request to a web server. It fetches HTML files, CSS files, and JavaScript files. It first parses the HTML file, then it loads the CSS files, and then they load the JS files, and then the code is actually run. So client-side rendering is good when you have to load a lot of stuff that's really dynamic, that really changes a lot in the website. So most of the consumer-facing applications that you're going to see in the web, they might, all of the majority of them are going to be client-side rendering. It's really normal thing. It's like, we're going to make it look bad in this presentation, but it's bad for our purpose. It's not bad for the overall web developer. Then we have server-side rendering, which is basically telling the server that we want the site, and they're going to build it there. They're going to send a full HTML document to us. Then we're going to receive the JS files, and then the browser executes JavaScript, and everything is done. So basically, the main difference is that on client-side rendering, the HTML document is made from the JS, and on server side, we already get the full document. So we're just going to attach event handlers and all that kind of stuff. So server side might be a lot faster than client side in this aspect, because we're going to have, instead of waiting for the HTML and JavaScript to be executed on the client, we're going to make the appropriate calls on the server, and we're going to save all that time. Static site generation is basically taking server side a bit to a more optimized stage. So we're going to tell all the information that we need for the website to be built to the server. And when the website gets built, all this information is going to be embedded. So it's going to be static. We're not going to be able to change it. And the main difference here for speed is that it's going to be served from a content delivery network instead of a web server, which is basically a server that specializes in serving static objects like images, HTML, or, well, static assets, right? So CDNs are much faster than web servers for this. But main thing is we are not going to be able to change, at least for now, the contents of these pages because they're going to be built statically, right? So let's have a quick example here. Imagine that we have a website, we have our homepage, and we might want to be changing the accesses on the top bar. So we might want to have about us page, contact us page, and we might want to add some, I don't know, privacy policy, for example. Obviously, it's a hassle for the programmer to go in the code and just add a new a tag and just link the other page. We can do all this from a headless content management solution if you opt to do that, if you opt to build this into your app. But we're gonna have to make the site be updated whenever that content changes. So it does make sense to use server side instead of static, right? Because on the server, we're gonna rebuild the application on each request, right? So if we make some change, if we change an image, if we change the text, if we change a link, whatever, it's gonna be rebuilt on each request. So we're always gonna see the updated results, right? Is there a way that we can use static site generation, which is faster because it's static and it's served from a much faster server instead of server? And we're gonna be coming back to this question later. So let's recap and discuss a very particular case that you might all have noticed. But before doing that, if anyone has questions, you can raise your hand, you can write in the chat and we can go over it. But if not, we can continue. This is for everyone to kind of chime in and tell us what they think about it. But have you noticed that whenever you Google some certain question about, for example, it might be programming, it might be whatever else, you always see some blogs from a big tech company, or it might be a more medium-sized, small-sized company. So, for example, the other day I was investigating about DNS and GeoDNS, which is basically how you can redirect the user to a more proper server when fetching the information from the servers. And the first article that came up was from Cloudflare. Cloudflare is basically a service that you can hire for the namespaces for your app, for your applications or whatever, and they specialize in this kind of thing. So why are these articles coming up? Why do big companies like this make articles? So if we write good content that is going to attract more users, so for example, I'm searching for a DNS solution, I might find this article, I might find Cloudflare to be a compatible option. So it's basically, we're going to use the SEO to kind of better index ourselves on organic searches. So if Cloudflare didn't have these blogs, then I would have never found them as a viable option. So we're going to leverage content. We're going to leverage blogs. We're going to leverage the speed of our site to come up in more searches. So basically, a speedy site plus a great deal of content that's relevant for our users is going to make us appear in more searches. It's not just about the homepage, right? We're going to need to have more content for the users. So let's go around this problem. So we might want to have a dynamic blog feature on our website, right? So actually, Howdy does have this. They have an integration with WordPress, so they can have their blogs served on the homepage. But imagine that we're a small startup and we really want to take advantage of the money that we're spending on ads, right? We want to make the most out of it. So we start creating content, we start writing blogs. How can we make it so that we come up better placed on organic searches? So let's start with the first approach that I mentioned earlier. We're gonna build this around server-side rendering. So whenever we build a web page, blog page, we're gonna add it to our content management solution. So I want to write about DNS, like Cloudflare. So I go ahead, I write an article, and I publish it on my server that serves all this static information to the site. Then we're gonna see the ID for the blog that this person is looking for, We're going to search the information, the content, the title, the images on the server. We're going to build that blog and we're going to present it. That's one of the options that server-side rendering for you. So we're going to search for the information on every request. Is there a way in which we can build it with static performance or static pages? Well, yes, we can tell the we can actually build static paths. We can search for other blogs that have been created at build time, and we can create them the same way, but on the web server. We can build the application to be static. What's the problem here then? Why are we going to choose server or over static or vice versa? Then the main issue here is what happens when we add a blog. So for example, we're building our site to be as independent from the engineering team as possible. We don't want to be going in rebuilding the app every time marketing goes and writes a new blog, right? We don't want that. That's just, we're engineers, we have to solve for it. So on server side, we got that covered because it's just, they have to add a new blog that's going to be indexed on the CMS. And then whenever someone searches for that specific ID for a blog, we're going to fetch the information and everything's going to be good, right? But we said earlier that having the site being statically served, it's much faster. So can we build that with static benefits? Well, that's where incremental static regeneration comes in. Basically, what this means is you can let the web server know if your content has changed. And if so, what pages need to be rebuilt. So let's picture this as you have a typo on one of your blogs, right? On a server side, that doesn't matter. You change it on the CMS, it's going to get updated when a new request comes in. But on static, you have the typo, right? You have the typo on the page, you need to address it. You don't want users to think that you don't know how to write. So marketing goes in, they start typing the article again, they fix the typo and they submit it. But our site has already been built. Do we trigger a new rebuild? No. We use the CMS to send a webhook to a web server. Then with all the information that we receive from the CMS, we're going to let it know that it has to rebuild that specific blog post. Or to rebuild, for example, if we change the header image for all the pages, then we're going to rebuild all the pages. That's incremental static regeneration for you. So now we can update only the pages that need to be updated, and we can still leverage the speed of a static site. There's, in Nextjs at least, there's two ways of revalidating a website. The first is manual revalidation. So, hey, build the website, build the page 10 seconds in. So if a person comes in before the 10 seconds, you're going to see the old version. If someone comes in after the 10 seconds, you're still going to be looking at the old version. But after the first request, after this time has passed, it's going to trigger a new build for this page, right? So that's the first way. This is not great because it's pretty much hard-coded, right? It's not smart. So let's build a smarter solution. Before building or going through the smart solution, we're going to see what happens is, for example, I don't statically assign the paths. So if you were building your site and you have 10 blogs, then those 10 URLs are going to be included in the sitemap, which is how we tell Google to crawl the site. And these are going to be available for the user. What happens if they access an 11th URL that's not on the sitemap, that's not been built because it wasn't there at build time, and we are leveraging static generation of the site? So then the first render is going to be served from the server. It's going to be server-side render. But then we're going to index it as static. We'll already have the page render, so it's going to be cached as static. That's it. It's pretty simple. So we don't have an issue with static pages and new content from a paths perspective. Then if we want to revalidate in a smarter way, we're going to want to use on-demand revalidation, which is basically you're going to build, you can see it here, you're going to build an API handler for the web server to take these requests from the webhook that you're going to fire from the CMS solution. Once you get there, you're going to receive some parameters from the CMS. You're going to use that to decipher what page needs to be rebuilt. That's how you're going to update statically generated content in a dynamic way. So we're basically pretty much at server side advantages, and we're leveraging static side performance. So let's take a look at the results, right? Because this is pretty much in the air. This is theory, it's not practice. It's really hard to imagine. So let's look at the results from our MetaSmart website. Take into consideration all these results. It's basically me hard refreshing the site. All the site is served locally, so these are local builds. And also, we're gonna go over this at the end again, but take into consideration that the cache from the pages is on my local machine, so that's pretty fast. There's literally no time lost there. When we have a site deployed on real life, we're gonna have a delay between the calls to a server. So all these results that we're gonna be seeing, these are gonna be much worse on real life than on my tests. Okay. So obviously, as I said, these are local builds. We're using the staged version of our CMS to feed all the content into a website. To measure performance, we're going to be using Google Lighthouse. This is built into Chrome's DevTools. You can also install an extension on Chrome. This is a static site. So we're pretty much the fastest as we can. This is a static site that leverages incremental static regeneration for site. It's pretty much the best you can hope for, right? So this is basically blazing fast. There's nothing faster. We can go back and we can pay attention to the metrics. So we discussed it first contentful pane. So the website is gonna start rendering at 0.3 seconds. And the largest part of the website is gonna also be served and rendered 0.3 seconds in. That's pretty fast. So it basically renders instantly. Then we're gonna have a speed index of 0.4. These results may vary. Each run is gonna be a little bit more consistent than the other. It might say 99 instead of 100. This might be 0.2 instead of 0.4. But for demonstrative purposes, this works. We're gonna de-optimize it a little bit, and we're gonna use server side instead of static side. So going back to the concepts, what's gonna change? We're gonna waste server time. We're gonna rebuild the site on each render, on each request, and we're gonna waste precious time on the server. How much time? We're gonna waste about a second there. So between the time I request for a site, it gets rebuilt and it gets served back to my browser, I lose, in average, 1 second. This is gonna be way worse when you experience it in real life, where the server is long, in a long distance between the client, and where the cache is also away from the client. We lost 3 points in performance. We didn't lose a lot in first contentful pane. That's fine. We lost 0.6 seconds here, and we lost more than a second here. So our speed index is way worse. So the site is quite good still, but it already lost more than a second in speed index. This might be hard to see, but the left side GIF is from the static side. The right side is from the server side. Don't focus on this animation here. There are some code differences between both code bases. Obviously, this is my production build. This is not. This is a forked version of our code. It's kind of stale. So focus on the hero images. You can see I'm refreshing the site here, and you didn't even notice. This is a refresh. This is also a refresh. You're seeing these images take some time to build. Everything takes a little bit more time. So we're gonna be seeing about the metrics. We're gonna also be seeing it about how the user perceives it. This is acceptable. It can be better. Let's optimize images, right? So we optimize for an issue that most people are not gonna notice, right? We're gonna be fetching data in different ways. People are not gonna notice. They're gonna notice about images. Images account for a big part of websites. You see images everywhere, and you have to optimize for the load of the images. If not, your website is going to have a big bottleneck here. Okay, so for image optimization, Next.js offers a proprietary image component. So we're going to be wrapping around the image tag for HTML. We're going to be making some improvements here. So we're going to serve the correct size for the image, right? You don't have to build any logic around it. If your viewport is smaller, we're going to serve the correct size for that image. We're going to prevent layout shift. This is basically when you come into a site, and while the site loads, everything shifts. It's really annoying. You want to click here, then the content is shifted down. Your button is down here. It's really annoying. It's not good for the user, and we're going to get faster load times. So how can we optimize the image's size and format? Well, Next.js automatically optimizes for format. It serves WebP or AVIF formats, which are more web-centric and more web performance. You can have static imports. These are going to have the attributes of the image. They're going to have the widths and heights. So that's how you can size the image. You can explicitly tell Next.js how big your image needs to be. Or if you don't know, which is basically a lot of the cases on the web, for example, if you have a big background image for the header, you don't know the actual size. That's going to depend on viewport size, on device size. You can use the field prop, which is basically going to tell the image to take as much space as possible. But you're also going to have to use the sizes prop, which basically creates a source set of images from the original one. What does this mean? If I have a 1000 pixel wide image, I'm going to build the source set around this, and I'm going to create variants on the server and per request that have several sizes less. For example, I might have the original one at 1000. I might have 700 pixels. I might have 500, 300. That depends on, and I think it says it here, it depends on the configuration of the breakpoints that you set on Next.js. So how does it work? So when the component gets rendered, you're not going to have the URL of the image, right? You're going to have a kind of different image URL. You're going to have the original URL here. It's going to be pre-appended by next image, and it's going to have some query parameters that are new for us. These are going to tell the next server the width of the image and the quality. Quality is by default 75, and width it's going to depend, as we said previously. This does not mean that's going to be the width of the image. That only means that that's the width that we're targeting. So, for example, if I have a configuration that says that the source set of images is going to be built around 300 and 400 pixels, we're going to approach 400 because that's closer to the target. So the final image is going to be around 400 pixels wide. Well, this is what I said. Width and quality are the parameters for building the new optimized image. Next.js uses Sharp. If you're using Verso, they're going to use the proprietary technology to resize the image, and then the image gets cached. And I think this is key here. If we optimized, if we try to have the image be exactly 384 pixels, that's going to be pretty much device dependent, right? If I use my phone, it might be 1 pixel wider. It might be several pixels wider. So it really doesn't make sense to cache an image that's going to be too specific to the device. That's why we use breakpoints, because it's going to be easier to cache and easier to serve. So this is what I said earlier. If you're using the field prop, you're going to be needing to set image size and device sizes as the configuration for Next to work properly. And this is a really key point here, because image optimization has a couple layers to it. So the image component lazy loads the images. This means that it's only going to load the images that come into the viewport, not the ones that are out of the viewport. And that's a big key difference between the regular image component and the Next.js one. We're going to be de-optimizing little by bit here. So this first, the optimization. We're basically changing the image tags here from Next.js to regular HTML, right? We replace the image component to image tag, and we see that the largest contentful paint is now actually bigger. So it's getting worse. We lost about 6 points in performance. Our speed index went up by, I think, 0.3 seconds. And you can still see that it's loading the images. But key consideration here, this image here, which is the one that's easier to see loading, is normalized for a website. This means it's an image that's cut exactly for that panel right there. What happens if, for example, marketing or whoever is in charge of updating the content doesn't actually size the image properly? So we're going to serve a much bigger, much heavier image. This is the second version of the optimizing. This image still looks the same, right? But it's not serving the same image. It's serving a much bigger and heavier image. That's the original one that wasn't cropped. And we still lost a couple points in performance. We're still losing in largest contentful paint. So it's taking more time to load the first content, which is the images. And we're still losing points on speed index. But we can still get further. Remember, I said image components load images lazily. What's down here? So what's the rest of the content on the page look like? We have some more sections. We have on the bottom, we have a blog section that basically links to other blogs. Those have images too. We have another section here that has a couple images. So we still can de-optimize further by making the page load all the images at once. And that's what we did here, right? We're still losing more points here, more points here, more points on performance. And we're getting a lot of warnings from the browser, right? Try to serve the images in a more modern way, reduce the server usage and a lot more. This might seem like not a lot, right? Font optimization. How can we optimize a font? What does it mean for us? So let's go walk through it and see. This is how it looked before, right? This is our de-optimized site. This is flashing. You can clearly see how everything's loading, but it's still kind of fast, so it works. Have you ever gone into a website and seen how the font loaded in? You saw a placeholder, then loaded the intended font, and everything just looked very 2000. Like we're back to the 2000s, and we just discovered the web, and fonts are loading in 1 second after we request a page. So why optimize fonts? Where this might be pretty straightforward, but it basically amounts to a really big part of the website. Then if you use custom fonts, you might want to use the ones that are built on the browser. That's not the case for many of the companies. They want to use custom fonts to differentiate them from the competition, right? Obviously, as the image is still, this can cause layout shift, right? Because fonts are different sizes. They're not standardized. So one font might be bigger than the other. And when everything loads in, the site might shift. This is really annoying for the user. How can we optimize with Next? It's really straightforward. It's really simple. It really does not require too much effort. You can use fonts that are already built into Next. Many of Google fonts are. But if not, you can also use your local fonts. You can use all the variants. You can specify them. You can build it. You can use the class name that gets built by Nextjs. And what's going to happen is the server, the web server, is going to download the fonts at build time. So we have the fonts. We're going to serve them as we did all the other things from a CDN, from a static server. So it's going to be pretty much fast. And what this means is when we request for all the static assets, we're going to also get the fonts. There's not going to be an additional request to whichever server that have the fonts. For example, you might want to use a Google font. You can use a pre-built CDN to get the fonts. That's an additional request for a font. So that's going to mean delay. It's going to mean layout shift. It's going to be pretty noticeable for the user. So let's check out the results. So you're still losing. So that's going to be constant here. We're going to still be losing points on performance, and you can see the font loading. That's just awful, right? This is refresh. It's taking too much time. That's because we're going to get worse speed index and stuff. but this is pretty much the time it takes to load the page. Then it has a delay on how it loads the fonts and the assets. So it's pretty much noticeable. If I went into a site and saw this, I would just back out, right? It's like, it's not good for the user. It does not paint a nice image of the company. Then finally, we have script optimizations. And this is a big part. For many marketing-centric sites like landing pages, you're going to have to build in some solutions for monitoring user usage. For example, Google Analytics, Google Tag Manager, Clarity, or some other tooling for this purpose. What is hydration? So when we get an HTML document from the server, does it know how to work? If we have a button on the HTML document, doesn't know how it should work. No, it doesn't. It's just HTML. It's just plain text formatted in a pretty way. So when the web browser actually gets the HTML file, it parses it and it builds the DOM, which is the document that has all the HTML tags there. And then it attaches all the event handlers. So now it knows how to work. Hydration is that. Hydration is when you're attaching the event, all the event handlers to HTML elements, basically. So we already have a script tag on HTML. And I see the questions in the chat. Just keep them coming. We're going to address them later. We have a script tag, right? This is HTML, and HTML already knows that we don't want the scripts to be blocking the time for HTML parsing or the site basically being rendered. So we have two attributes that we can use here. The async one basically tells, hey, you can download the font, you can download the script on an asynchronous manner. Doesn't matter, you can download it as everything is loading, as the HTML is being parsed. Once the script is downloaded, the HTML parsing is going to be stopped. So you're going to be blocking the main thread. And then it's going to get loaded, then the HTML parsing is going to continue. That's not ideal. Then we have the defer attribute, which basically tells the browser, hey, you can download the script async, and you can just load it after HTML is done parsing. So a combination of the two is preferred, but we can still do better. We can use the script tag from Nextjs. We have 3 new props here that are going to change the behavior of how we load the scripts into the site. Before interactive, this means we're going to load the script before any Next.js or hydration runs. So maybe we really need to make sure that the script is already there before the user interacts. Maybe it's really, really, really important for all the metrics to load before the user interaction occurs. After interaction, that means you can start hydrating the site. So HTML parsing is done, the DOM is already built. You're going to start attaching event handlers. That's after interaction. You're going to wait for part of the site to be interactive, and then you're going to load the script. And then lazy unload is basically wait for the browser to finish everything and then load the script. I found useful to use after interactive for stuff like Tag Manager and Google Analytics, right? So we're going to see the performance implication of this. So before that, you can pre-connect to the origin so that the browser knows that you're going to ask for something to that origin. This makes it a little bit more faster. This is not Next.js related. You can do this in HTML, but it's good to know. So these are the results. This is finally the optimized site. It's taking too long to reload, right? And it takes too much time to actually have the content displayed on the site. We lost pretty much all the performance gain here. We were at 0.4, we're now 2 seconds up. We were at 0.2, we're 2 seconds up, and we were at 0.2, we're 2 seconds up. Here, we have layout shift. It's small. Luckily, the font that we're using was kind of similar in size to the Apple system one, so it didn't shift the layout too much. But we didn't have it before, and the speed index is just really bad. And the performance, we were at 100%. Now we're 24 points below. This is really bad. in the time, and you can see this here in the final comparison, but in the time that this side, the optimized side, loads one time, we can load the optimized one about 20 times. That's a lot of time. So for final comparisons and final considerations, remember, this was all hosted and served locally. So this means the cache was really close to the client. That's not how it usually goes. The only thing that was pretty much far from the client was the CMS, but everything was built statically on one side and then served on the other. So ideally, the CDN servers are going to be pretty much far away from you. They're not going to be in your local machine. So all the performance that we lost, that it's going to be worse. Your site is going to be much, much worse than this. You're going to lose more than 1 second on server time. Imagine that 1 second was locally. So if you're going to be losing, I don't know, 2 seconds, 3 seconds on the server, and this is a final showdown, right? How can you know this site is reloading? It's pretty subtle. We don't have this animation here because I removed it on production, but see this indicator here? It's flashing. That's one reload. Every time it flashes, it's one reload. You can even see the image is reloading. It's really, really fast. In this GIF, this reloads about 5 times. In that time, this reloads one with some lag, right? You can see the images that are coming later. You're gonna see the font loading in. It's a really bad experience, and it's gonna be much worse if this was a production site. So thank you for this. I'm gonna be reading the questions now. Yeah, just feel free to kind of leave them in the chat or just say it out loud. So about incremental regeneration, let's say I have 10,000 posts every time I deploy. It will generate 10,000 again. Isn't that stressing on the API or DV? So yes and no. And I've actually been thinking about this for some time now. But there's, as far as I know, there's no way around this. So imagine that we're not MetalSmart. Imagine that we're not a small startup. Imagine that we're Reddit. Pretty big company, right? Reddit might have billions of posts. And every time you search for something, they come up on the search results. How do they do this? How are they indexed on every page, on every blog that there's published? So one idea that I had is basically leveraging incremental static regeneration to let kind of like build the pages with time. You don't have to serve them statically at first. You can serve them over time. This is gonna kind of not delay the builds that you need to ship. This doesn't exist yet. It might be a viable option in the future. This doesn't exist, but I can reassure you that 10,000 posts are gonna take like 30 seconds to build. It's not gonna be long. You're gonna be doing this every time you rebuild. Yes, it might be stressful for the API, but it's just one per build, right? Again, you might want to build this application. For example, if you don't want to be rebuilding the blog application every time you rebuild the landing page, you might want to leverage a monorepository architecture. You might want to leverage that and build a separate blog application that also leverages all these performance implications. So for example, if we change something, if we add a page on the landing page and you need to rebuild the landing page, it's independent from the blog functionality. So that might be a good approach to it. I've also had this doubt. I don't think there's something that kind of resolves it completely, but it might be something interesting to look at it and kind of try and find a solution. You can try and leverage incremental static regeneration to build async pages, right? That's a really great question, Dario. I see Dylan has another question. When reevaluating the blog post page after fixing the typo, how does that request look like? Is it a comparison of versions number for the page? No, you actually have to build an endpoint on the web server. We're gonna call it the revalidation endpoint. For security purposes, you can add like a secret, you can add a validation key to actually know that the server that's asking for this revalidation actually has access. And the payload of that request is going to contain, for example, imagine that we're changing the homepage. It's going to say, hey, you're changing the content homepage. And that's all we need. If we're changing the homepage, we're going to revalidate the homepage. Let's look at another example. Imagine that we're changing the header. So that basically affects all the pages. We're going to see that the payload says, hey, content change header. And we're going to revalidate all the pages. How does this look from a code perspective? Well, for example, we on the endpoint script, we have an object that has all these attributes. So, for example, we identify the object that's being changed on the server, and based off of the name of that object, we have an array of pages that need to be revalidated. That's a great question. I don't think there's more questions. I'm not sure. No, I think there's no more questions. But feel free to make them. And I created a Notion document. I can send them on Howdy channel with all this information. It's a little bit more specific, but yeah, that's basically breaking fast for you. Thank you everyone for listening in and making questions. Hope you learned something today, and now you can stop teasing frontends about just changing colors.